Welcome everybody to this talk. I will explain a little bit the mystery behind this multi-signature crypto wallets and how it's considered to manage shared funds at ICO projects or many other scenarios. Thing which is not most common, very common in the industry, but it should be, because currently when people create ICO projects, they just trust someone of the founders, and he just manages the wallet. And if something happens with him, it's interesting. But first, I'm just Nakov. There is no need to explain more. I'm the main driver of the software education in Bulgaria and the biggest initiatives here. And together with colleagues, we write books, we create videos, we create thousands of video lessons, and in the last year I'm involved in the blockchain. I was a technical advisor of blockchain, where it raised something like 10 million and successfully has a decentralized booking platform. I was part of this project and I no longer keep touch with them. I was creating technical trainings for software engineers, and I'm also advisor in many projects related to crypto investments and crypto things, mostly at the technical side. So I will talk first about the problem with the single person managed wallets, then a little bit about the concepts of these multi-signature wallets, and later how the thing started with the Bitcoin from its very beginning, these scripts, the complexity behind it, and how this technology was slightly improved in the Ethereum network, where smart contracts entered into the game and simplified things. Finally, I will demonstrate you how easy it is for the end user to use the Gnosis wallet and many others, but my demo will be based on Gnosis because it currently manages hundreds of millions and it's proven technology. So let's start. The typical scenario: someone creates an ICO, he has good marketing, big dreams, nothing really dumb, but exceptional marketing. He managed to collect millions of funds. Typically, people just get one key. What I have seen in the practice is one person is trusted and he has a wallet. This is one scenario. Another thing is we have a wallet, we have mnemonics, and these mnemonics are split, and half of them are kept in one safe, the other half is kept in another safe. This doesn't work. Because, for many reasons, reasons are many. First, we can lose the key by mistake, or we can get hacked, or something can happen, including physically. For example, the computer or the hardware of the person who managed the money can be hacked or compromised. Yeah, and this happens. This happened even to Bulgarian ICO projects. And they lost a lot of money, but for different reasons. Some illegal activities may happen. The founder can change his mind and just keep the money and go at the Caribbean tropical islands. I want to send you some photos about the future of your funds. It might happen to someone just to be forced. Someone comes, puts a weapon here and says, oh, you have a wallet, hardware, you have the PIN now, just save your life. And it might be an accident. People fly a lot with airplanes, and it might happen that someone just disappears, or some incidents happen. So managing a lot of money under a single user managed wallet is not good. And traditional banking system have a solution for this. If you die or if something happens with someone, the bank can manage these funds to be unlocked by some descendants of the person, or somehow they have solution. But in the decentralized world, we have to find a technical solution, because the concept of decentralization is that there is no central bank and things like that. So the first thing is that if you want to have a single key which operates with the company's money, you can split it. And please don't split the key like this. We have, for example, 200 bits of data, and we split it by 4 portions, the first 4, the second 4, and so on. This doesn't work because it's vulnerable to attacks. For example, if you have 3 out of 4 pieces, the last pieces have the 4th time, it's easier to crack. It's hard to explain. So there is a Shamir secret sharing scheme based on the Lagrange polynomial interpolation, which is pretty simple. Even non-mathematician could find this concept very easy, and I can demonstrate this. If you go to, for example, bitaddress.org, you can generate a wallet, and this wallet consists of some public address and some private key, and the private key is encoded by this polynomial point, this polynomial point, and this polynomial point. And if we have a polynomial of 3rd degree, is defined by 3 points. If we have 2 of 3, it's impossible to decode it. So splitting keys is better managed like this. So the idea here is that if we have 3 people who everyone has 1 piece of the key, any of them, 2 of them together, can recover the key. So if we combine the shares, these 2 shares or other 2 pairs of these shares, we can combine the key. This is a better way to manage private keys and shared secrets to be split between several participants. And in the start of the crypto exchanges, it was very modern to have 1 server which gives the funds of everyone, and when someone wants to withdraw money, the server just signs a message and sends a transaction over the net. Many crypto exchanges were hacked, and people learned to use multi-signature wallets, and the procedure was completely different. To withdraw money, for example, from Bitfinex, you need a few, for example, 5 different signatures. So 5 separate people should be hacked consistently in the same time to be able to withdraw money in an unauthorized way, for example, in these big exchanges. So let's dig more about this technology. The concept of splitting the secret key like this is just mathematical way to do it. It's very positive and very useful in this situation. For example, we can have 2 out of 3 signatures or 2 out of 3 shares split scheme, or 3 of 5 or 2 of 3, and they're different, and they can serve in many cases. For example, you can use additional key which can recover together with some shareholder just for a backup reason. If some shareholder disappears, to avoid permanently locked money on the blockchain. You can use this for just like a democracy key. For example, if you have 5 co-founders, we can decide by having 3 signatures out of these 5 people. And this is how it works, for example, in Bitcoin Gold. Because I have friends, Martin, you know him, he pays their salaries just by collecting enough signatures between the co-founders. So at each month, they have a multi-signature transaction, and they just collect enough signatures in order to approve the money. So no one from the co-founders can just take the money and go to some tropical island. So the concepts of multi-signature wallets or multi-signature addresses or multi-splitting of some secret key is to give a way to manage assets by these N out of M signature schemes, which means that if we have, for example, 2 of 3 signatures, it means that at least 2 signatures, 2 people out of 3 owners should confirm some action, transaction, or something in order for this to execute. So when we use multi-signature wallets, there are several steps. The first is creating this multi-signature wallet. In Bitcoin, it's just creating an address. It's called an address. You put 3 keys, and some scripts are generated for the Bitcoin virtual machine, or the Bitcoin script. And you assign owners. These are the shareholders. These are the people who together manage the funds. For example, we can have 5 shareholders, and to take a decision for paying something, you need 4 signatures, 4 out of 5. And usually we can change these owners over the time. They are not constants because in the company, in the structure, people can change. And this happens in usual. You should have another action. Submit a new transaction. Just someone from out of these owners proposes a transaction and says, please submit these transactions for approval. And it starts to collect signatures. Collecting signatures might be just take the transaction, send it by Telegram messenger to the other person, he signs it, he sends the output to another one, etc., etc., or can stay on-chain. I will show you the on-chain solution. We have sign, which executes several times until enough signatures are reached. Once the signatures are reached, finally, a transaction is executed, and this transaction is signed by all these people, and the logic inside the smart contract or inside the script signature of this multi-sig address is executed, and it validates on-chain that all these signatures are correct, and all these people agree to spend this money, for example, or execute a smart contract action or some blockchain transaction. Okay, so in Bitcoin, it's a little bit more complicated. If you go at some Bitcoin online wallet, like this one, for example, you can create a multi-sig address. It's related to addresses. So these addresses take as an input when you create a new multi-sig address, you put the public keys of the owners, of the people who need to manage. The algorithm generates you a multi-sig address, and this address is encoded. The logic behind spending after 2 out of 3 signatures for these public keys is encoded in this script default. It's in fact a program. This script is a program which just executes some operations, some checks, some calculations, some signature validations, etc., etc., etc. And later, you create a transaction. How you create it? You just use your wallet and take the binary data. For example, pay to Todor 5 bitcoins and to Maria 10 bitcoins because they put some work for our project. And we take this transaction. For example, this one, this is a real transaction, this one, which is something like take this input and we have this signature, take the other input, we have 1 out of 2. 2 signatures are needed to execute, but we still have 1. This is just an example, and this is the transaction. It encodes what to pay, where the money come from, where the money go to, etc. In Bitcoin, it is more complicated because it uses the so-called UTXO model, the spend transaction output. So the place where the money come from are these 3 transactions. So these are the 3 coins we spend when we do this, and these are the payments for the addresses. In Ethereum, it's more simple because we have 1 person who pays, 1 address, which is the source, and 1 recipient. Here it's a little bit different. So I will not talk further about Bitcoin because it's the more complex. I will show you how easy it is to use this technology even for your everyday work. Even if you don't have an ICO, or if you have, for example, few friends collected some money to invest in crypto projects, for example. They may want to manage this money collectively, not to rely, to trust just to one of them. So in Ethereum, this is implemented as a Solidity smart contract. For example, this contract. Why I give you this example? The reason is very simple. This contract is proven. This is just an example, but it's very well audited from the security perspective. And this contract is written by Stefan George. And I will not enter in very big details, but it's just something like it keeps a list of all waiting transactions, it keeps list of all owners, and executes some logic. For example, to execute a transaction which is already registered by ID in a map inside the contract, it should be signed by enough people, it should be confirmed, and then it is sent over the network and is executed, which is this is hard to read even for Solidity professionals because it's assembler. It's low-level code. But this is not the interesting thing. The interesting thing is that this contract already for just single instance manages 86 millions. Oh, it was 80, just 80 this evening, but maybe that is going up. But just an example, this is used in a real-world scenarios. This is not just an example, just a test or something else. So the most important data functions in this contract is creating new contract. You just supply your addresses and the threshold. For example, you supply Peter, Maria, and Nakov. These are 3 owners, and we put the number 2, which means that 2 out of these 3 people can decide whether to send or revoke a transaction. We can submit a transaction to the wallet and sign in. The person who submits this transaction also signs in because it usually comes, this section comes together. Confirm or co-sign means that you just provide the transaction ID, which you already have sent at the previous step in the contract, and confirm it. And finally, when enough signatures are collected, you execute it and you say, please now execute this transaction and do the payment, or do the contract invocation, or do the token transfer. So finally, I will show you a live demo because this is not for technical people. If you are familiar with crypto and you are not developer, you will be able to use this tool. This is just a web app. It's wallet.gnosis.pm. Why I recommend Gnosis or some proven technologies? Because if you write the multi-signature contracts yourself, it is more likely to have security issues, and which will means that someone will take your money. And if you use something which already manages hundreds of millions, it's more unlikely to have a security problem. And yes, it happens, the Parity multi-signature contract was hacked, and even Eternity lost some funds in the past. This happens, but still Gnosis multi-sig wallet was not hacked. I will show you this in a live demo. So, what do we have? We have this wallet.gnosis.pm. And I have created some wallets. So, for example, I can create a new wallet, and here I put the owners of this wallet, and the name, and how many confirmations I need. For example, I have 5 people at the down list, and 3 out of 5 for this. I have already created a wallet, and this wallet has 3 owners. So, the first owner is Nakov, which has this blockchain address, the second is Mariah, etc., and the third is Peter. So these people, I run this on the Ropsten testnet. You know it, it's a playground where you play with virtual coins, so these are not real letters, which costs money, it is just a playground. So I will use this MetaMask. MetaMask is a browser plugin, which is a wallet. It manages my funds. So I have 3 accounts: the Nakov's account, Mariah's account, and Peter. Usually, these people will have 3 separate laptops, but for the demo, I have just one, and it will be easier to show you just by changing. So, currently I switched to Nakov, and I am Nakov, and Nakov's account is this this one, 598, etc. So I can tell that I want a new transaction. So I will pay, just to take an address, I will pay to our web designer who is Ani, and just to copy her address, I will pay Ani, for example, 2.5 Ethers, and that's all. So instead of sending a normal transaction and signing in, I will send a multisig transaction, which is some kind of transaction request. So I sent a multisig transaction, and it says, oh, it's impossible to do this. Do you know why? Because I switched from Nakov to Ani. Currently, this is not my account. I will return back. I switched it to Ani's account just to copy her address. That's why. So currently, I'm Nakov, and I sent this. It says, oh, please give some gas price. I will say, for example, 2 gigaways, and it's done. Now the MetaMasks will tell me, oh, do you really confirm that you want to start a transaction request signed by you to collect in the next few days, for example, some signatures to pay Ani this amount? Of course, you can connect your Trezor or Ledger hardware wallet, and I never recommend to keep real money in MetaMask. This is a bad idea. And usually at home, I use my hardware wallet. But here we use just the test ethers, Ropsten, and MetaMask. So I confirm this transaction, and we have a multisig transaction over the network. This is my contract. So this is the smart contract which collects, and now I have a pending transaction, this one, which says, please submit transaction. So I want to pay this address, this value, something like this. It will be mined in a few seconds, and the next step is to switch and to simulate that we are the other person. For example, I will impersonate myself as Mariah. Mariah is the other co-owner of my wallet. Okay, now I'm Mariah. The account address here will be changed, see? And now I can refresh. If the transaction is mined, see, it stays here. So someone requested to pay this account this money, and this is the data. So this is a transaction which is waiting, and it's already signed by Nakov. Hey, Mariah, do you confirm this? You can confirm or not. This happens on her laptop or on her tablet. This is a separate machine. So now I'm Mariah, and I say confirm. And I just sign this, and I say, oh, I confirm this. I need to put some details for the transaction execution. For example, I will pay more bigger transaction fee to wait less time. And now Mariah signs the same transaction which stays on-chain. It stays inside the contract, which is different than in Bitcoin. In Bitcoin, you don't have on-chain waiting transactions. And now some time should come, and when it passes, when the transaction is mined, this will disappear and it will be switched to executed no. So see, currently, until the mining has happened, Ani has 0. And Mariah has something, and the account balance of this wallet is still 2.5. Yeah, maybe it's already passed. Yeah, it passed. So the smart contract balance was reduced, and this passed. So this is how it works, and we can see at the smart contract that we have some execution of this transaction execute, which transfers from the contract address to the Ani's address. Yes, confirm transaction. So it's really simple. You just go to wallet.gnosis.org.pm and please use hardware wallets. If you really have millions of funds, just spend $100 to purchase hardware wallets. And that's what's my talk. I hope you really to stop managing millions just by 1K and by one person, because persons sometimes disappear, especially in the Bulgarian business industry. Keys can get lost, and it's really simple to use this technology, and it's reliable.
Thank you very
Questions?
Much.
Hello, Svetlin. How vulnerable are the hardware wallets?
Hardware wallets are more secure than your laptop. To hack your laptop is pretty easy by keylogger and many other browser plugins which do the job. Hardware wallets are harder to be hacked. Still, there are some exploits. First, you should be sure that you get the wallet directly from the factory, not from someone, because some attacks are based on someone gets some wallets, he opens the wallets, changes something, injects some keylogger or random generator manipulator, and package it and sell it to yourself. So generally they are safe because the private key inside the wallet cannot leave the wallet. They use the technology called the secure element, which is a hardware like in the credit cards with the chip. This chip guarantees that the private key cannot be extracted. There is no way. But someone could trick you to use to store a private key which is previously known by manipulating the random generator, or in fact, yeah, generally, please use the latest version of the most trusted hardware vendors, and they take care. Just like if you run the latest Apple software and you use Apple and you don't install third-party sheets, your laptops should be safe. You should trust someone. Yeah, and it's better to trust a hardware wallet instead of someone else. Absolute security is not granted, but usually people get the wallet, put it in a safe, and it has a big vulnerability because when you install the wallet, they print everything inside it just as 24 mnemonic phrase. And if you put this phrase on your deck, someone can take with take a snapshot with his camera and you're lost. This is a big problem in the industry, and these people are really stupid. This is a proven way how not to do it. You have a hardware wallet which is protected, and you have everything which is inside printed on a sheet of paper. And they say, please lock it. What the fuck? They should split this at least a few pieces and lock it at another location and the other thing at different location, but they don't do it. So hardware wallets are generally safe. Yeah, if you take care to have the latest updates, the latest software, to purchase them not from China for better price, but from the original producer, they are safe.
What about these new services which are popping up, which are like custodian services? So they take the security, let's say, burden away from you. Let's say they're in like Switzerland, they're in a mountain somewhere,
Yeah.
they store your private keys, and then you can kind of just, so let's say you raise 10
This
million.
is a solution, but this is centralized solution.
Yeah, but also,
So the question is that there are third-party services which keep your keys and manage them following some policy. For example, if you prove that this is you, they can recover your private key even when you don't know your password. It is the same with the bank. If I prove that I'm Svetlin, if I don't remember my account, but I have a proof of person who am I, they will serve me. This works, and it is centralized, which works as long as this service is provided by a trusted party, because it's all about trust. The centralization comes because people don't trust the central bank of the United States because they print dollars. That's why we have blockchain and Bitcoin. And But for some services, we prefer to trust the government, to trust the notary, to trust the banks, to trust these organizations, because it solves different problems. So I believe the future is a mix between that. They should not be alternative, use Bitcoin, don't use dollars. No, merge the Bitcoins with dollars, because it gives more decentralization, but still gives you the benefits of the official system. For example, if someone steals your money from the blockchain, you can call the police. Now you can't.
Guys, have more questions?
Yeah, this guy.
I think this is the last question before break.
Merci de la lecture. Sorry, yeah, I switched to English. So we know what happened with parity. There are a lot of ETH locked there. So how can we be sure that the same thing won't happen with Gnosis multisig?
Generally, we cannot be sure. Someday the quantum computer becomes reality, or the people who have it reveal the secret, we don't know. All Bitcoin transactions and wallets will be broken, because if you have a signed transaction, you can recover by a quantum machine. It's proven mathematically that you can recover for just few seconds if you have powerful enough quantum computer. You can recover the private key from the public key. This is proven by mathematicians. This is not theory. So I think that it's like the open source. For example, most people trust Linux because it's there for many years, and still, in few years ago, there was a book in OpenSSL, which is open source. It's used many times. The same is with this contract, but I believe it's more secure because it's just 200 lines of code, and OpenSSL is tens of thousands of lines of code. So the other thing is, if the other use it and manage hundreds of millions, they should be more aware about security than me, and because I will keep just few thousands. So this is how I'm thinking. Absolute security is impossible, but it's secure enough, in short.
Thank you very much, Svetlin, for a great speech.